Okay, ladies and gentlemen, so this is just some extra practice for those of you that either missed or aren't still quite super confident with the combined gas law. All right, so I realize that the numbers over on the side here are off of your packet, but this is the second page of the combined gas law practice. I'm just going to run through the questions so that you have some extra here. Okay, so I hope that you've tried these yourself, or you are going to watch one and then try the other two and then check your answers, but please use this the way that you're going to learn, not just because I told you to watch it. Okay? Now, a sample of gas has a volume of this at 60 degrees Celsius. So I'm going to stop right there and I'm going to write out V1 is equal to 4.20 liters and T1 is equal to 60 degrees Celsius, meaning I have to convert that to Kelvin. So that's going to be 60 plus 273. That's going to be 333 degrees Kelvin. You have to convert the temperatures to Kelvin, and your pressure is 1 atmosphere. All right, so I want to calculate the pressure, so I want P2. If the volume is changed to 5 liters, so V2 equals 5, and the temperature is 27 degrees Celsius. 27 plus 273, meaning T2 is 300 degrees Kelvin. All right, so considering I have all of my variables and they are all shifting, I'm going to need to use the combined gas law. So that means P1 V1 over T1 equals P2 V2 over T2. All right, now this guy can be found in the back of your reference table. You don't have to memorize it. So now I'm going to plug in. So I'm going to take P1 is 1 times 4.2 over 333 is equal to P2, I'm going to leave it as P2, V2 is 5 over 300. Alright, so the way I'm going to solve this is by simplifying the left side first. So I'm going to plug in 1 times 4.2, and then I'm going to divide by 333. Okay, and I'm going to get 0.0126, let's add a 2 in there, 126, okay? And that's going to be equal to P2 times 5 divided by 300. So I'm now going to multiply my 300 over, so times 300, and I'm going to divide by 5, okay? Dividing by 5, and that will get me P2 is equal to 0.75667 atmospheres, or if you want to round, 0.76. Alrighty. Next, a certain gas occupies a volume of 55 milliliters at STP, which tells me quite a bit. What would its volume be at 27 degrees Celsius and 1,000 milliliters? Alright, so let's write out what we know. So my P1 has been told to me based on STP. That means 1 atmosphere on the front of your reference table. Okay, V1 was given to me at 550 milliliters, and T1 is told to me in STP, 273 degrees Kelvin. Now I want to know its volume, so that's V2 is a question mark, at 27 degrees, so T2 is 27 plus 273, because I need to get it in Kelvin. That's again 300. And a 1,000 milliliters? I think that probably means 1,000 atmospheres. So let's see what we got here. Ah, I see it. So we're going to edit this question just a touch. We're going to look for pressure. What would its pressure be? Okay, so we're not going to look for V2. We're going to look for P2. And our V2 is going to be 1,000 milliliters. I'm sorry. Typo. That should be pressure. Okay. So what we are now going to do is write out our formula. So we're going to have P1 V1 for T1 equals P2 V2 over T2. Alright, so now let's plug in. So my pressure is 1 atmosphere. The volume that we have written down is 550, and the temp is 273. All right, pressure is what we're looking for, P2. Our V2 is 1,000, and our T2 is 300. So I want to simplify this side first. So I'm going to go 550 divided by 273. Then I want to multiply over the 300, so times 300. And then I'm going to divide by 1,000 to isolate my P2. Okay. And that means my P2 will then be equal to 0.604 atmospheres. Okay. Alrighty, on to question 3. Airbags are an important safety feature. Yes, yes. An airbag is inflated in milliseconds by the explosive decomposition of NaN3. The decomposition reaction produces N2 gas as well as Na solid according to this unbalanced equation. So balance the above equation using the smallest whole number coefficients. This is a little bit of review. Maybe you can just do it real quick. I see N2 right here, so I want to have the same number of N's. That one's got 3, so I'm going to pop a 2 here and a 3 there, giving me 6 and 6. And I need to put a 2 there for my sodium then to balance. Alright, so we did A. I left you an ungodly amount of space to do that question. Alright, now, when the airbag inflates, the nitrogen gas is at a pressure of 1.3 atmospheres, a temperature of 301 Kelvin, and a volume of 40. Calculate the volume of the gas at STP. Alright, so my P1 is going to be my 1.3 atmospheres. My V1 is going to be 40 liters, and my T1, 301K. Okay. P2, V2, and T2. So it seems as though I'm calculating the volume, so I'm going to put a question mark there. And then they tell me STP. So that means 1 atmosphere at 273 degrees Kelvin. You just have to know that that's what STP means. It's on the front of your reference table for you to look it up. You don't have to memorize it, but don't be confused by STP. Alright, so now I'm going to plug and chug. I've got P1, V1, T1 equals P2, V2, T2. Alright, so let's plug this guy in. So P1, 1.3 times V1 is 40 all over 301 is equal to 1 times V2 over 273. Alright, so I'm going to simplify the left side first. 1.3 times 40 divided by 301, and that's going to give me 0.1727, and there's more in my calculator, and that's equal to V2 over 273. The 1 drops, this really doesn't do anything, so I'm going to multiply this number by 273, so times 273. Okay, so ultimately my V2 is equal to 47.16, and I'm in milliliter, or I'm in volume, so that means I'm in liters. Alright, I hope this was helpful to you. If you need any other assistance, please let me know. I do have additional practice if you would like to do some more practice. Alright, thanks.